AP Statistics. Awesome. We are going to talk about sample size in this video. It's going to be off the hook. You're going to love it. So here's the deal. Sample size questions come up all the time, and let me tell you why. Because of the CLT, central limit theorem. Because the central limit theorem tells me that as my sample size increases, my variability or spread, what does it do? It decreases, right? So when I talk about variability, I'm talking about standard deviation, because standard deviation is a value that measures variability. So often we want to decrease variability, and so if we want to do that, we have to change our sample size. So notice, if we want to reduce variability, one thing we can do is to increase our sample size. So we need to learn how to do this. So there is a shortcut. If you just want to cut your variability in half, let's say, all you have to do is quadruple your sample size. Let me show you why. So look at this right here. Since your standard deviation decreases at a rate of the square root of n, so remember, that's our formula. So the standard deviation, we're dividing it by the square root of n. So if we want to take a sample 4 times as large, it reduces your standard deviation by half. Here's an example. Let's think about this. Let's say I want to decrease variability by 1/2. Oh, can I spell the word by? By 1/2. So let's say I've got standard deviation and I want it to be half of what it is. So half, this means the same thing as half of the standard deviation, right? Okay, so if that's the case, I need something in the denominator that is a result of 2. Well, how do I get a result of 2 from a square root? Well, I take the square root of 4. Are you with me? Okay, so that means that if I want to half my standard deviation, I've got to have a sample size 4 times the size it is, because 4's square root is 2. Isn't that beautiful? Okay, let's do another one. Let's say I want to decrease the variability by 1/4. So now I want to have this situation. Well, what square root produces a 4? That's right, kids. The 16. So that means you would need a sample size 16 times as big. Huh? Pretty cool, huh? I know, math is fun. It's magical. Makes the world go round. You're welcome. Everything hinges on it. Okay, it's not that serious, but all right. So let's do some examples for sample size. And I'm sorry that I've had to scroll through here and show you all this stuff. All right. So example 6, I'm a graduate student. I randomly sample. I just made up a word. See how gifted I am? A sample. All right. A sample of 25 CHHS students, and I record their IQ. I get a mean of 136 and a standard deviation of 2.4. My professor tells me that for the purposes of my research that the standard deviation is too high. So I want to reduce it to no more than 0.6. What sample size would I need? Okay, there's a couple of different ways you can go about this, all right? And it really doesn't matter to me which way you do it. One of them is complicated, one of them is fairly easy. So you can think about it this way. 2.4, if you'll think of it this way, go ahead and if you'll just divide 2.4 by 0.6, you will find that 0.6 is 1/4 of 2.4. So because 0.6 is 1/4 of 2.4, all I have to do is I have to make that sample size 16 times bigger. All right, so because you can think of it this way. Remember, my sample size, if I want it to be 1/4 of what it was initially, and I do, it is 2.4, I want it to be 0.6. So I want it to be 1/4 of what it is. So if I want this, that means that I would be taking the square root of 16. So that means I'm going to need to multiply my sample size of 25 by 16. and that's going to give me 400. So that is the sample size that I need right there. Okay, another way you can think about this. If they give you the initial standard deviation and what we want the standard deviation to be, you're going to take what I have over what you want it to be. You're going to square that and multiply it by your sample size. You could do it that way because what you have is 2.4. What you want is 0.6. Square that, multiply it by 25, you get 400. Okay, there's another way to do it. I know you're excited. This way's a little trickier, and it's only going to work for those of you who are very algebraically minded, so I'm just going to give you a warning. So keep in mind that my standard deviation formula looks like this. This is what I have found to be true from my 25. But remember, this formula requires that you have a standard deviation, and we weren't given that standard deviation. We just know the standard deviation for these 25. So we don't know the initial number they started out with. Therefore, I am going to cross multiply, and I get that that initial value they started with was 12. So that means that I want to see what n should be if I want the standard deviation to be 0.6. So again, I cross multiply. I divide by 0.6. I'm going to square both sides, and is 400. You get the same result no matter which way you do it, and I don't care which way you do it. Okay, so let's look at number 7. Let's look at a different situation. The counselors are working with SAT scores and take a random sample of 60 CHHS students. They show a mean for the math SAT of 580 with a standard deviation of 12.8. If they need to reduce the variability to 1/8 of that, what sample size would they need? Okay, so again, we want our standard deviation to be 1/8 of what it is. So what you need to do is you need to find what 1/8 of 12.8 is. Well, it happens to be 1.6. So you can take what you have over what you want and square it. Why am I squaring it? Because of the square root. And you can multiply it by your sample size. That is the easiest way to do that. Or you can do it like this, or like this. Either one. It does not matter to me. Okay, let's look at example 8. In an experiment on a new medicine to treat viral infections, Andy takes a sample of 50 cultures, finds the virus population declines 8% in 1 hour. This gives a standard deviation of 0.0384. The lead biologist says they need to achieve a standard deviation of no more than 2%. Please be careful. This is 0.02. What sample size will Andy need? Okay, so again, I'm going to follow the same pattern I did in the other two. The standard deviation I have over the standard deviation I want squared times my sample size. So I have 0.0384. I want no more than 0.02. That gives me 184.32. I'm going to round that. Awesome. It's very magical. So keep in mind, if on this particular question, it's important that you round up, and let me show you why. The lead biologist says they need to achieve a standard deviation of no more than 2%. Remember, larger sample size, less variability. I don't want it to be more than 2%, so going up is preferred. Okay, so we're going to round this up, and it will make a difference on the AP test, so be careful with that.